Here's a quick video about finding patterns for sequences, just some examples for review and study. So here's a sequence. I've given just the first 5 terms of the sequence, and we'd like to get a pattern for that, or let's say the most obvious possible pattern for that. And it's always a choice that we can make as to where to start the labeling of the sequence. That's an artificial label we impose on it, but most likely we are going to choose n equals 1, 2, 3, 4, 5, etc. Don't have to, but if you don't choose that, you should advertise it. So the first thing to do is always check to see if it's one of our 2 special simple examples that we have really spent a lot of time on. Is it arithmetic? Is it geometric? And if not, does it have pieces that are those, and maybe we can put it together out of those pieces? Well, to test if it's arithmetic, we see if there's a common difference d. And indeed, this is minus 4, minus 4, minus 4, minus 4. So this guy's just going to be an arithmetic sequence with d equals minus 4. Okay, and then a1 is 15. And then we've got a general formula for that. A sub n is just you start with your first value, and then you repeatedly add in the common difference. Okay, well, in this case, that's a minus 4. And how many times do you add it? You're comparing, let's say, a5 to a1, where you started. How many jumps did you do in the sequence? How many iterations of subtracting 4 are you doing? That's n minus 1. And that minus 1 is an artifact of the fact that we started counting at 1, which is standard but not ideal. Okay, and then we just simplify it a little bit. Looks like it's the minus 4 and the minus 1 make a 4, and that's 19 minus 4. So there's our simplest form. Okay, that's going to be very useful, and we'll do another video where we take that and do more with it. Okay, so what's another one? Let's look at, say, b sub n is 18 minus 6, 2 minus 2/3, 2/9, minus 2/27, etc. Okay, so is it arithmetic? Okay, you can take the common differences. This is subtracting 24. That's adding 8. No, it's not. Is it geometric? The ratio here, minus 6 over 18, is minus 1/3. 2 over minus 6, ooh, that's minus 1/3. Minus 2/3 over 2, 2's cancel, oh, minus 1/3. And you can check. They are all exactly the same ratio. Okay, so it is geometric. Yes, that's great. Okay, so we know that our master pattern for that is going to be our first term. Okay, we'll call that b1. I don't want to call that a right now because that'd be a little confusing. b1 times the common ratio, which we just found. And again, we've got an n minus 1 here. It's again an artifact of the same choice that we're usually labeling this as the first term, the second term, the third term, and not starting counting with 0, which would be prettier. Okay, so we're just basically done. b1 is 18, and then times minus 1/3 to the n minus 1. Let's check it. If n equals 1, which we're using as our label for the first term in the sequence, this completely dies, which is the point, and you get 18. If n equals 2, you get minus 1/3 to the 1, and 18 times minus 1/3, that was minus 6. Okay, and then you're just multiplying repeatedly by powers of minus 1/3. Notice that the first few, it's a little hard to just read off that ratio, but if you actually look at these guys, you see the pattern better. That it's alternating signs. That's the kind of thing you get by a negative power, a negative number repeated to various powers. And you can see the powers of 3 showing up here with the 2 on top, which is part of what came with the 18 because it was divisible by 2. Okay, so again, we're going to do more with that sequence in another video, but I wanted to sort of separate them out so you don't have to watch too much if you're only confused about certain things. Okay, c sub n. Let's say that's minus 4/10. This will be a little more complicated. 5 100ths, minus 6 1,000ths, 7 10,000ths, minus 8 100,000ths, etc. Okay, so if you look at the differences, that's adding, what is that? It's complicated with hundreds and 10. You'd have to put a common denominator. If the difference here It's not good, okay? The ratio, maybe a bit of a better chance, because the denominators are going up in a geometric way, which we'll use in a second. But the ratios of 5 over 4 minus 6 over 5, 7 over minus 6 is not good. So you should always check that. Is it arithmetic? Is it geometric? And if you don't trust me, take the ratios and the differences. They're not all the same. Okay. So this is one where we want to look at it as different parts, and maybe it's something where it's some of our standard examples like arithmetic and geometric put together. Okay, and of course there's other sequences that you just have to be more clever about, but not usually like on a test as more one of the more straightforward problems. Okay, so let's look at the top. You've got these numerators. Let's not worry about the signs quite yet. Oh, that is an arithmetic sequence. Okay, if I just did that, 4, 5, 6, etc., that is just going to be n plus 3. It's an arithmetic sequence with difference 1, so it's just n plus or minus some value. And to make it match up with the first n value, giving 4, it's just going to be n plus 3. So that's nailed part of it. Okay. What about the bottom? We'll do the signs last. The bottom, as I already observed, that looks like geometric growth. Those are powers of 10. It's a nice thing about base 10 is that those show up very easily. So 10, 100, 1000, etc. Okay, that's going to be 10 to the 1, 10 to the 2, 10 to the 3. Oh, and if n is 1, 2, 3 here, that's just going to be 10 to the n. And then an alternating sign is a very, very common pattern. Okay, that's either going to be minus 1 to the n, or minus 1 to the n plus 1, or minus 1, and minus 1 is maybe slightly more standard for us. Okay, they give the same thing, because adding 2 just means multiply by minus 1 squared, which is 1. Okay, so which one is it? Well, we want to start out with negative when n equals 1, so it's this guy. This guy is very, very common because often you start out with positive, but not always. Okay, so let's put it all together. See if I can fit it in here. Yeah. C sub n is minus 1 to the n. That nails the sign. And then on numerator n plus 3. And on the bottom, 10 to the n. Okay, so a bit of a more complicated formula, but put together out of pieces that are actually our two standard examples. Okay, and if you want to know more about like summing these guys up, that's what's in another video.